We're going to begin this lesson by reviewing some questions that some of the students have in several of our past packets. And then if we have time, we're going to move on to similarity statements where we talk about similar figures. Similar, I guess there's a proper way to say it. Okay, Sherry, just read the problem to me, okay?
Okay, x subtract 3 divided by 4 equals x divided by 2.
Divided by what?
2,
Is this correct?
yes.
Okay. Okay, so the very first thing we're going to do when we look at this is to decide, we like to do that cross multiplying now, but we have to make sure that it's a proportion. This would be, it's in the packet. It's in the proportion and ratio packet, which is packet number 1. And then it's toward the back. Let me see if you've got it numbered. Well, maybe it's not. Maybe it's not toward the back. It is page 9. It starts at the top. It says solving proportions algebraic expressions. It's the only one that says algebraic expressions. And this is number what, Sherry?
1.
Oh, okay. The one that she's working, the remote, I have to explain. It is an extra practice page, and I can print that for you if you guys want it. It's just another page like the algebraic expressions, okay? So that's what we talked about. I'm going to let Isabel in. So this is an extra page. So you can write this on your notes somewhere. Okay, so we have to decide if this is a proportion or not, because we cannot do that cross multiply. It doesn't work unless this is a proportion. So the definition of a proportion is 1 fraction equal to 1 fraction. This is not extra stuff because it is part of the numerator. So what we said is if you have a plus or minus as the top or the bottom of a fraction, it actually is a set, and it will help you work these problems if you put the parentheses around that set. Okay, so we have established that this is a proportion. So now we know that we can cross multiply to find the answer. So it doesn't matter, again, which way you multiply first. I'm going to write this down just because I just do. So the 2 will go in front of the set. It can go behind, but it might be confusing. So I have 2 times the set. 2 times the set equals 4 times x. Now, if you remember from yesterday, I will encourage you to put arrows. The reason I put arrows is so this doesn't be confused with an x, which is a times, and then you begin to confuse yourself. So use arrows if you're going to write this. Equals 4x, 4 times x. And then we get to our equations that we already learned how to solve, but this is new to us. So we've done it several times, but relatively new. So we don't know what x is, so we can't really find a number answer in here, but we do have to get rid of the parentheses. So what we do is use what we call the distributive property, which says to distribute this outside number over everything that's in the parentheses. Since it's crammed up here, it's multiplied. So the distributive property says multiply this and then multiply that, and then we'll get rid of the parentheses. The number in front of the x is an invisible 1, so when we multiply here, we're going to have 2 times 1 is 2, but it has an x with it. So it is 2x, bring down the minus, then 2 times 3, which is 6. Are we good, everybody? And then equals 4x. Now we have everything outside the parentheses and now it looks more familiar. Now, usually we put the line down through the equal sign and we circle our variable, but we found out earlier on that if the X is in too many places, it's hard to circle one X. So that gives us the clue that we have to get all the X's together, okay? So that, I always think in my head, silly stuff, but silly stuff helps me remember things. This looks like a fence line to me, and this is somebody's yard, and this is somebody's yard, and everybody's having parties. Well, the X's got split up and the X's are on too many yards. We need to get all the X's back to their party, okay? Or back to their barbecue or whatever they're doing. So we can either subtract 2 X's off of here to get them gone, or we can subtract 4 X's from here and get those gone and they'll come over here. It does not matter which one you do. It does make it easier most of the time if you will get rid of the smaller one. Okay, then you don't deal with negatives as much. Okay, so let's go over and grab this guy and put him back over there. That means he has to leave this place. So I'm going to subtract 2 X's, and before I do anything, we have to balance the equation. Don't get in a hurry to do your math until you put both pieces. I've seen too many students forget to put the second one because they get all worried over here. 2 X's minus 2 X's is zeroed out. So now I have a -6 left in this yard and 2 X's here with the equal sign on the line. Now that the X is in one place, I can circle it, okay? Every time I work like this, can you guys see? Do you need to move? Okay. Okay, now I want the X by itself. It's multiplied to the 2. I know that if it's multiplied, I have to divide. So now I have -3 equals X. Did you follow it, sweetie?
Yes, ma'am. The only thing that I messed up on was instead of doing the cross multiply, I was working it like a regular algebra. Like I took the 4 and I was going to unlock the barn up at the top. You know what I'm saying? Up at the top, instead of cross multiplying it, I was working it like a regular algebra.
Were you were multiplying across?
No.
Oh.
Okay, I started with the 4 up underneath the X and the -3.
Yes.
And I was going to get rid of that 4 like we do in regular algebra. And it come out to be the right answer. I said, but this don't feel right. This is just not right. And
well, actually, Sherry, the more you learn about algebra, the more different ways you find out that you can do one problem. So if you did it that way and you stayed perfectly legal with everything you did, are you saying, I want to get rid of this 4?
Yes, and I got the right answer. I said, but
you will. If you multiplied by 4 on this side and multiplied by 4 on this side,
I did.
Then this canceled. Now I'm showing Sherry that her procedure was correct. Don't be confused here, okay? So if you multiply by 4 because you wanted to get rid of this, then you did it correctly because it's equals. So you balanced your equation. This went away and then you had X minus 3, right?
Yes.
Equals X over 2. No,
Yeah.
no, when you cross cancel here, this became 2X, right?
Okay.
Or you got 4X over 2, did you?
Well, what I did was I took the 4 and I multiplied it by the 2X. So I come up with 8X. I think I threw my paper away.
Well, getting 8X there probably is not.
I don't know, Miss Deborah. I worked it 2 or 3 times and I did come up with the right answer, but it didn't look right. And I said, this is not how you do, this is not a proportion. This is regular algebra. And so that's why I texted you. And I tried to do another one and I just got aggravated and I just put it away.
Do you see how now?
Yes, yes.
Okay, beginning that one where you took 4 times each side, and if you did it legally, it's still okay because you were doing the math legally. So it would have been fine, except when you got over here and you started multiplying and got 8x. I'm not sure about that side. Okay,
Okay.
so that's where I'm concerned about that part.
Okay.
Any others on that page? It doesn't hurt to practice. It's helping with y'all, or y'all know how to do it. You're like,
Yeah.
okay.
Yeah.
All right, Sherry, did you decide if there was another one?
No, no.
Understand it now?
Yes.
All right. Well, what I'm going to do is move to the next part, Rachel. It's your part, so
Okay.
I'm going to be answering a question. No, go ahead. Go ahead. Okay, she's getting coffee, and this is the one that I want to help. It's on this page, and the reason that I'm going to go over this page, this is in packet 1, is because some of our students had came in after we learned how to plot points. So I'm going to review that for them. Okay, I'll go ahead and write the T-chart on the board, and then we're going to use our whiteboard over here. Okay, and I will go ahead and begin here and tell you that when you have an X and a Y and you want to plot this, it looks a little strange in this kind of T-chart. Another T-chart that you might be able to see makes more sense. The X is -5, the Y is -35. So when you have an X and a Y, this is the point that you need to plot on the graph. Okay, so -5, 35. Now, I want to call to your attention that on this particular graph, look at it carefully. Are you on the right page? Yeah. Okay, on this particular graph, on the x-axis, it counts by ones. But look on the y-axis. They had such a big number, 35, that they marked each block was 7. So you've got to be careful how they marked the graph. Everybody, you okay? All right, let me make sure everybody's here. Hi, Isabel.
Hi.
Okay, so when you graph a point on your graph, so since the -5 is the x, that says we're going to go the direction the x goes, which is horizontal. This is the x-axis. This is the x. This is the y-axis. Let me turn that. Multitask. Okay, let's put, there are our numbers right there. Okay. So the horizontal axis right here is the x-axis. The y-axis goes up and down. So the direction that we're going to move for the y number is up and down. I'm going to change these numbers right now so they look like the graph. So this is -7. This is -14. This is -21 and -28. 7 times 35, is that right?
Yeah.
-35, and we'll go one more,
-42.
-42. Okay, it's a mess, but I want it to look like what your graph looks like. Okay, so we are going to graph, that is 1 point. So we don't put a dot on every number. We just put a dot on when we get through moving. Okay, so the x-axis goes this direction. When we move for the y number, it goes this direction, okay? So we always, when we're plotting points, we always start at the origin, which is 0, 0. Now I'm not going to put a dot there because it's not part of our graph. So we're going to go -5 on the x-axis. You begin here, 1, 2, 3, 4, 5. This thing counts by 2. It's kind of weird. Okay, so we're here, but we don't put a dot here because I still have to go up and down to a -35. So I'm going to move down until I'm on the same line as the -35. You see? Okay, the next point says that I'm going to go -4 on the x-axis right here, but I'm going to go down -28. Are you following me? Then -2, 1, 2, and it's still negative, so I go down 14. So here, and oh, I kind of screwed that up too, so I'm going to screw it up. 7, 14, 28, 21. Okay. So the next one says that I'm going to go right and left a +2. Do you see where I am?
Yeah.
I'm going to go +2. So I go to the right, +2, and up 14. And then I go +3, which is right here, and up 21. Now, we all know I can't draw a straight line, but I will try.
You're fine.
So this, do you see that when it's graphed, it's a straight line and it goes through the origin? That's the definition of a proportion. The graph has to be straight and it has to go through the origin.
Okay.
So when you graph this one and you see that it's straight line goes through the origin, you say it is proportional. So they're reviewing you on plotting points, but then you use that information to decide if it represents a proportion or not. Are you good?
Yeah.
Okay, do you need another one? Probably not.
I can actually see the plots.
You understand it now? And then you can ask questions.
Yeah.
That's okay?
Yeah.
All right. Any questions on that, y'all?
No.
All right. Let's go to the next one that I wanted to talk about. This is in your packet that starts rate and unit rate right here. But it is this page. If you numbered it, it's page 5, comparing unit rates. Now, if you followed what I told you before, you're going to use the numbers they give you and set up a proportion. This is you are going to set up a proportion, excuse me. You are going to set up a proportion, but in this case, they want you to find unit rate, and I'll explain why. this first one says Jack and their orchards had a harvest of 450 pounds and 1215 pounds of oranges respectively. Now, I want to make sure that you understand what the word respectively means here. I want you to look at this carefully, because if you don't understand the words, then you can't do the problem. Okay, so when it says respectively, that's not respectfully. That's not being polite to somebody. This says respectively, says in the same order. So what they're saying here is that if they said Jack first, then Mo second, then the numbers they gave, the first one goes with Jack and the second one goes with Mo. That's what respectively means, so they don't have to write a bunch of extra stuff. Okay? So if you see respectively, it says go in the same order as I just started. Then it continues to say Jack had 6 orange trees and Mo had 15 orange trees. Whose orchard acquired the highest yield? Now listen to this. Per tree. That's per one tree. They want to know what is the unit yield. Yield means what I got off those trees. The oranges I got, yield. They want to know for Jack's orchard, how many pounds did he get per one tree? Okay, so what we're going to do is take the information we know about Jack. We're going to figure out the unit cost, and then we're going to find the information that we have about Mo, and we'll find his unit price, and then we will compare those. Okay, so the information they gave us about Jack is that it was 450 pounds and trees. Those are the things we're comparing is trees, but we're comparing it for each person. And they said Jack had 6 trees. Okay, so they want to know how many pounds. Well, let me show you this real quick. Over here, they said that Mo had 1,215 pounds, but he had 15 trees. Now, when you look at this, this is hard to compare who had a better yield or who had more oranges per tree. It's hard to tell. That's why we need to have a common denominator. Well, in this case, we want to have one. We want the unit rate. So we're going to find the unit rate right here. Now it said per tree. That means per one tree. So we're going to set up a unit proportion, one tree, right? And then we're going to find this. We're going to find the answer for Jack. Then we're going to come over here and we want the same denominator. So we're going to find the unit rate for Mo. Y'all see? And when we have one as the same denominator, it's much easier to compare our numbers on the top. So let's do one at a time. This says Jack had 450 pounds of oranges for 6 trees, and we set up a proportion. We said we don't know how many oranges for every one tree. So we're going to work this problem. We're going to say 6x equals 450. Now, Brandy, you asked me the other day about another way to do this, and you go ahead. It's fine.
Okay.
Do you remember?
I'm exactly where you're at right
Okay,
now.
that sounds fine. And then we continue to solve by dividing by 6. And I don't have my calculator out, so
75.
say it,
75.
75. So Now, remember, it's a written problem, so 75 what?
Pounds.
Pounds of oranges, right?
Right.
Well, the trees are here. One tree has 75 pounds, okay? So now we know that Jack's on every tree, he got 75 oranges. Now we're gonna come over here to Mo and do the same thing so that we can have something we can compare. So over here, we do another problem. 15x equals 1,215 oranges. We're going to divide by 15.
81 pounds.
I'm really sorry about my hearing. Tell me again.
81 pounds.
Right. So has 81 pounds of oranges. Be sure and use your units because it's a word problem. Okay, now it says who has the better yield? Who gets more oranges off their trees?
Mo.
Mo. Okay, and that's how you do this. See, if we have the denominator of 6 and a denominator of 15, it's really difficult, almost impossible, to just look at it and compare. But if you change it to a unit price, compare your units. And that's how you'll do everything on this page. Okay? In the beginning, somebody tried to take this equal to this, which is what I've been teaching you all along. But if you want to compare two different things, you need to pull each one of them down to the unit price. Okay?
Miss Deborah,
Yes.
I noticed that you were you started multiplying the bottom number, the 6 times the x first. I have been multiplying the top number first and then the bottom number. Does it matter?
It does not matter at all.
Okay.
It will come out exactly the same.
Okay, and before you move on, there was another worksheet I wanted to ask you about.
Okay.
It's in unit rate.
Okay.
It's the one that has the graphs on it.
Okay. Is it the graphs that are already done for you or the ones you have to make?
Yes, they're done. It says find the unit rate for each graph, sheet 1. I don't know if I
Okay.
have my papers numbered
I
right.
think it's this one. Hang on.
Page 2.
Let me pull it out. Oh dear, different. Okay.
Yes.
Is it this one?
Yes, ma'am.
Okay. And it says find the unit rate for each graph.
Yes.
Unit means what is the number for just one thing? Okay. So here's what you're going to do on this one. This first one has to do with, let me see if I can get hold of this. Okay. If you look here, this represents the number of rows that I have in an auditorium or something. Let me hold this still. How many rows I have in an auditorium and how many chairs I have in each row. Okay?
Yes.
So you always look at the X part and you say in one row because unit price is 1. So you say the unit rate is how many chairs? I can't see that number. If you go to 1 and go up, yes. So down here, you're going to say 20 chairs in 1 row. You're always going to look for the 1 on the x-axis to find the unit rate. Unit rate means 1, okay, unit.
Okay, because I didn't know what they wanted. I'm like, I don't know. This sheet don't give enough information. I don't know what they want.
Okay, now
Okay.
look here. We have height and time. Let's look at the x-axis. They want the unit rate. So they want, how high did you get in 1 minute?
1.5.
Feet, right? So
Yes.
you say 1.5 feet in 1 minute because unit rate is over 1. Are we good?
Yes, thank you.
That's what that means.
Okay.
Any other questions, remote people? Any other questions up until now?
No.
Okay. Josh, I didn't say hi.
Hello.
Okay, do you have any questions on any of our past stuff?
No, not on none of that.
All right. So we're going to start on the packet that I sent to you yesterday, packet 3, and it starts similarity statements and has some triangles on the front. Okay?
Okay.
And I have a student here that wasn't here yesterday, so I'm going to make sure she has one of these. You probably don't have this. We handed it out yesterday. We handed 2 of them out. This is what we're starting on right now, Brandon. This one is what we're doing now, and this one we will be using next week. Okay? Did you find it? Yeah. Okay. Okay, similar. If you have figures that are similar, definition means okay, this is what people usually say. Same shape, different sizes. That's an easy one to remember. I want to move on and say it's the same shape and they have proportional sides. Definition, similar. And I will show you what I mean. But first, there is a symbol that means similar. And it's a curly Q, one little curly Q. So if I say triangle ABC is similar to triangle DEF, then I mean that the sides are proportional. Then it is also important how you write this because the order that you write the letters in tell you that it is AB, side AB, that's the line like okay, here are your triangles. Yeah. If you write the letters in this order, it means that side AB is proportional to DE. You have to do them in that order because sometimes they're not going to give you, even today, they're not going to give you where they're all faced the same way. This one might be turned a little bit. So you need to pay attention to here. It tells you which ones are proportional to each other. Okay, just listen. I'll pull it together in a minute. Okay, just hang in there. So this says that AC, okay, I'll do AB, is proportional or similar to DE, just like we said right here. And then if you said AC, side AC, it's proportional to DF. So the order that you write this in, or that they give it to you in, is the clue which side goes with which side. And you'll need that later on. Okay, now similar. Let's do this. Let's do okay, same shape, different sizes, right? Now you're not positive that these are proportional until we see the measurements on the sides. Okay, and the way we tell it's proportional, let's do this. Whatever, inches or whatever. And then I'll have, okay, let's say inches or centimeters or whatever, okay? So what I'm saying is, I'm gonna name this. Now, we have to make sure that we understand corresponding sides. That means in the shape that it is, which sides are the same shapes. You know what I'm talking about? So the little one on the bottom and the little one on the bottom are called corresponding sides. They're not equal because this is 5 and that's 1, but they are corresponding sides because they match the same position in the triangle. So this long side and this long side are corresponding sides, and the hypotenuse here, those are corresponding sides. So if you set up a proportion, or if we say, let's set up a fraction between corresponding sides, okay? So if I want to set up a fraction with this corresponding side, I'm going to say AB, and y'all don't have to write the AB over DE, but I am indicating that I am going to write down this number. And y'all see AB, DE, y'all see? So the fraction that I'm going to write down here is 15, because that's the length of AB, over 3. Now, if I simplify this fraction, it will come out 5 over 1, right? Let's do the other sides. Let's do this one and this one, okay? So I'm going to do, I started with the big triangle over the little triangle. That's important. So you do everyone, Rachel, come on, stand up. So I've got BC over EF. So the length of BC is 5. And EF, I went from big to small, is 1. And it already is simplified. And if we did this side and this side, we might as well do this side, okay? And so I'm going to write a ratio of AC to DF. And that would be the length of AC is 25. The length of DF is 5. I went big to small because that's what I'm doing every time. Stay in the pattern. And when we simplify 25 over 5, what do we get? 5 over 1. If the simplified fraction between the corresponding sides is equal on all 3 sides, it has to be all 3, then these are indeed similar triangles. And the way you would write that is a triangle ABC, and this is how we indicate it, triangle ABC. And remember, if I named it this way, is similar to, I have to use the same order. So my sides have to match. AB matches DE. E, have to put it in the same order. So I would write this. When I found out that the proportion between the corresponding sides is the same, then I indeed know that these are similar. This triangle name followed by the same pattern are similar to each other. Yeah? Sorta?
Yeah.
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 So let's do the first question now. Do y'all have notes for this? This is a lot. It's something new. We're not going to go very far, but I will tell you a secret for later. If you want to know the secret, do you want to know the secret? Okay.
Yes, we do.
This ratio, the simplified ratio, is called a scale factor. We'll be doing it later. Keep this in your brain.
More work.
The simplified ratio here between the 2 similar triangles is the scale factor. If you will notice, the next packet that I gave you, that I sent to y'all in remote, is called scale factor. So I'm giving you a preview. Okay, so let's go to the actual worksheet. And I'm not going to give you very much, but I'm going to try to give you enough since we're not going to have class tomorrow. We will continue similar triangles, similar figures on Monday. Okay, let's look at the actual worksheet.
Do the numbers have to actually go in ABC order?
No.
Like how you did it?
No, you could say CAB.
So can I do it like this? AB, because they're similar, right? Well, like you were explaining,
Yeah,
and
it
then
says-
EF. So
Okay.
this one.
You
over
could
this
say
one.
AB is corresponding, yeah. Mhm.
Okay.
So this over this, but when you do your next one, make sure you start at small and go to big. If you started small and went to big, always go small to big.
Yeah, right here.
So, so you're doing AB
Mhm.
and you're
And then
doing over EF.
Okay. And then
No,
it'll
the
be-
letters do not have to go in order, but they need to go, they need to match when you do a similar statement.
Okay.
Good question. I like the questions. Okay, let's do the first one. It said, and now all they want here, let me go on down. There we are. It just says complete each similarity statement. So they start very easy with you. It says 42 inches. This is the first one on the first page of this packet. 48 inches, 50 inches. And this is D, this is F, and this is E. This is the way that they write it. This is C, B, A down here, 25 inches, 21 inches, 24 inches. Do you think we ought to decide if they're proportional before we say they're similar? We better do this. So tell me what, okay, DE. You don't have to do this on this page, but I want you to go through the process. Side DE, what does it correspond with? It corresponds with what side?
CA.
B and A.
CA, okay, with CA. That's good. So if those correspond to each other, let's make a ratio out of that. So let's do DE over CA. Okay, DE is 48. You don't have to do any of this. We're practicing. I'll tell you what you put on the answer sheet. Over 24. Okay, CA is 24. If you simplify that, it becomes 2 over 1. And remember the ratio, one of the rules in ratio said, even if it's a whole number, leave it over 1 if it's a ratio. Now let's look at EF. EF corresponds with what? Is it
B and A.
with EF is, say it again?
B and A.
Let's do it in the order.
A, B.
First, and then F.
Okay.
So let's say AB. Now
A,
the
B.
length would be the same, but let's get used to doing it in the exact same order so there's not any problem. So now we're going to do, we started with the big triangle on top, so we've got to do the big triangle on top. So EF over AB equals, EF is 50 and 25, which simplifies to 2 over 1. So we're good so far. And one more time, y'all know where I'm going. How about DF corresponds, oh, there it is. I'm spelling all this thing wrong. Corresponds. Okay, DF corresponds with what? CB, that is exactly right, CB. And we start, when we do a ratio, we started with big, have to start with big. So we have DF and the ratio to CB equals 42 over 21, which simplifies to 2 over 1. Since the reduced fraction or ratio is exactly the same on all 3 sides, this is indeed proportional, which makes it similar. Now, after doing all this, because I need you to understand it, all you have to write in here, they said complete each similarity statement. So they start the statement by this. They say triangle DEF is similar to, and then it has a blank. So all you have to do, since we know it's similar, and the ones on here are similar, this is good for you though. So you have to write the other triangle in this order to make a similarity statement. So what are you going to put? Triangle?
Or no.
CAB. I heard somebody say it. Not sure who it was.
Mary.
Was it Mary?
Yes.
Good. So side DE will correspond with CA. Do you see? They need to be in the same order. Do y'all understand what I'm trying to tell you?
Mm-hmm.
All this stuff is not required on this first worksheet. None of this is. It's good practice to learn it. All they want is to know that you know which sides correspond with each other and you can write them in the correct order. Because when you have a similarity statement, the DE has to match the CA. The EF has to match the AB. And the DF has to match the CB. Do you guys see? It has C. It will be clear when you see it, right? Okay, so this is what you put on that first worksheet. Are you understanding how similar works?
Yes.
That's because I'm sorry. Okay, and if we go back, because I like to plug this in, this number right here, this ratio, is the scale factor. We'll be finding the scale factor in our next section. So not only are we testing to see if the sides are proportional, when they are, we already know the scale factor. Okay, and the scale factor most of the time will be written with a colon, 2 to 1. The scale factor will be written with a colon, giving you a head start. So that is worksheet page 1. Am I wearing you out already? I've already been worn out. Let's just go to page 2. We'll just do the first 2 pages of this section. If you want to move on, they talk to you about the scale factor on page 3. But I want you to look at page 2 now, and if you will notice what they're wanting you to do, write whether each pair of triangles are similar to each other. That means you're going to have to see if the sides are proportional in the same ratio, just like we did. Okay, and I'll help you do the first ones. You notice that the difference on this page is that they're not sitting in the same direction. So you've got to be very careful and either redraw these in the same direction, or if you can make your brain move it, then you can do that. So here's how we're going to do the very first one. Now this one, this particular page, they're not telling you whether it's similar or not. You have to decide if the sides are proportional. I'll try to draw this. Nah, don't like that. What, critics? Such critics. That's better. There we go. And this says 4 inches. This one says 2 inches. And this one says 3 inches. And then they show you another triangle. That looks like this. And they say 8 inches, 6 inches, and 4 inches. Now the instructions say, write whether each pair of triangles are similar. So you're going to be saying yes or no. Okay. So what we're going to have to do now, if I were you, I would put letters on these. Okay, it might help you. So if we look at the smaller side, here's the smaller side. That helps, right? And if you can turn this in your brain, turn one of them so they're facing the same way, then it's easier to do. You've got to think here. You can't be sleepy. So every one of them that doesn't have letters, just to help you out, I would put ABC and use the other one as XYZ, okay? So from A to B, that means this is the This is the one that looks like it's perpendicular. It's here and straight up. So here is that one. Okay, we're going to call that Y. Because X, Y, and Z is what I'm going to do on the other one. Okay, so the other side of the small one, this is how I figure it out. I don't know if I'm confusing you or not. The other side of the small side, I'm going to call X. That leaves the point up here. So the high point is C here. We're going to call it Z. Now, if you're very careful about putting the letters where they belong, then it's much easier to do. Okay? So I want to show that A, B, C is similar to X, Y, Z. However you want to figure these out. So that means that I need to compare AB over XY. So I've got 2 over 4 equals 1/2, right? Everybody got really quiet. And then I want to do BC and YZ. So BC is 3 and YZ is 6. And that simplifies to 1/2. And then the last one, I want to do AC and XZ. AC is 4 and XZ is 8. If the simplified scale factors are all the same, then your answer is going to be yes. They are similar, and you will write this because this is true now. Triangle ABC is similar to triangle XYZ. Okay? You will say, yes, they're similar, and then practice writing it.
Is this right? I don't think this actually whether each pair. Okay. So instead of doing X, Y, Z, I just kind of did it with
DEF.
Yeah.
But you got the right ones. So AB and DE. Yes, that one's correct, and then you need to simplify. BC is a straight up and down. D. But BC is 3, and DF is 6. Oh. And in this one, CA is 4, and that's the slant, and FE, because you already have BF. Okay. So this is the long side, it's the long slanted side. Okay, do this, so this would be CA and EF. This one takes a lot of thinking, and that's why I'm not going to go any further. I want y'all to try these.
Okay.
So even if you have to trace these, cut them out, and turn them the same direction, that will help for a lot to get your head straight. Or you can trace one, turn your paper, and
So it's A, B, B, C,
CA.
and C, A.
So you've got A, B, B, C, and CA.
Okay. And then you have
The one that goes with AB, you've got a D, it's the short one, okay? So it goes with the short, and you did that correctly.
and then I did that twice. Oh, no,
Now,
it's 6. How did I write 8? Maybe I'm dyslexia.
That doesn't look like dyslexia, that looks like coloring. Okay. Then you did CA, so find CA. CA, okay, this was 4. Now we've got to find out which one is first.
So this, I have this backwards. It goes DF or FD.
Goes here.
Oh,
This is the slant, this is the
EF. So I'm able to use it twice?
No,
So why do I have it in
this one is, okay, AC or CA, right?
Mhm.
Okay, and that 4 is correct.
Mhm.
Now we've got to find the one that corresponds, and that's this one, which is EF. And EF is 8. You got so you weren't even.
And now I'm simplifying this, right? So
Mhm.
that would be 1 and 2.
1, 2.
2,
You divide
That's
by
gonna be
1,
3, 1,
2.
2. And then that's gonna be 1, 2. Because it could go in there.
Mhm, mhm. And so if all of these are the same, then you say yes, similar.
Similar. Okay.
I don't know how they do that. You say, yeah, just similar.
Okay.
Not similar, similar.
Okay.
Okay?
Okay. So it's really the same thing, just without the letters. Like,
Yes, yes, yes. Okay, now one idea I had is if you have trouble switching the, turning these around, which is the hardest part of this, is turning them around, then maybe you could just take a clear piece of paper and draw this one. And then turn it around where it's the same shape as this one and draw the bigger one. Trace the bigger one. Might make it easier if y'all understand what I'm saying. You would trace the smaller one, just trace it with a piece of paper. Turn your paper around until it matches the direction of the other one. And then trace it also, so they're going the same direction, if that will help you. Okay, I'm gonna throw you to the wolves. We're just going to work on those first 2 pages right now. I don't want to go too far with you. Just page 1 and page 2 of the triangles. If you didn't number your pages, this one is the first page. This says similarity statements. It says L1, S1. And on this page, they're pointed the same direction, which will help you on the first page. The second page that you will be working is the same idea. It says similarity of triangles this time. And up at the top, it says sheet 1. This is page 2 if you number your pages. And in this one, they will be in different directions. Well, that one's the same direction. Different, different, different. That one's just flipped over. Different, different, different. So find out your own way to switch these around, turn them around so you know which sides correspond with what. Okay? It's going to take some really heavy duty thinking. All right, guys? You can do it.
I just have another. So am I doing that right? I know that this is the smaller side.
Yes.
So do I go A, B?
You can put your ABC anywhere you want to. It's just where you put the next 3 letters that matter.
And I want them to match.
The
order.
corresponding sides, yes,
Okay.
yes.
So like, so A, B, and then that would be C, that would be.
It'd be this
D.
one.
Um,
Wait, that's a shorter one, isn't it?
Yeah. Mhm.
So it'd be this one.
This one.
Mhm.
Okay.
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 All right. Any questions on that? We'll do some clarifying on Monday. We're not going to go any further. Are there any questions right now, though?
I
No.
don't have any.
I didn't totally wipe you out,
No.
sorta? Okay.
7.
Answer it after this, okay? So go take an aspirin for your headache and then look at these and see if you can figure out corresponding sides. Okay? And we'll talk about it. Remember that
Okay.
you can text me anytime during the weekend. It's just that I won't be at a place that I can teach you. But as soon as I get your text and as soon as I'm free, then I will answer you. Okay? So you don't bother me if you text me on weekends. Be sure and talk to me,
Okay.
okay?
Okay.
But I'm finished for today. I think it's enough, don't y'all?
Okay.
Yes.
See you Monday. Have a good weekend.
Okay, you too. Love you guys.
I love you too.
Bye.